In this video, I'm going to take a look at factoring trinomials that have a leading coefficient of 1. So our trinomials will be in the form of x squared plus bx plus c. This would be something that a beginning Algebra 1 student would learn, one of the very first things that they would learn going into factoring. Alright, so basically we have our trinomial here. We've got an x squared minus 14x plus 24. Okay, now what we have to do is we need to come up with two numbers that multiply to a positive 24 but add to a negative 14x there in the middle. So initially when you start to do this, it would probably be a good idea to make a nice organized table. I need a product of a positive 24. I need a sum of a negative 14, and it'll be a negative 14x. Alright, so what I'm going to start doing is I'm going to start listing two numbers that multiply together to be 24. So in other words, products of 24. Alright, so 1 times 24. Okay, but now if I sum that, I'm going to get a positive 25. Alright, if I have two positive numbers and I add them, I'm going to get a positive number, but I need a negative 14 to appear in my sum column. So that's going to tell me that I'm going to have something else that's going to multiply together to get that negative 14. So another way to get a positive 24 would be to multiply a negative 1 times a negative 24. Then when I add going across, I get a negative 25. Alright, which is obviously not the pair I need. I need it to be that negative 14 in the middle. So then I'm going to just keep trying, listing all these products that add up to positive 24. If you do it in a systematic manner, you're going to be able to more likely find it quicker. So there was 1 goes into 24, negative 1 goes into 24. Alright, since I know I need negative 1, so let's go with negative 2. So a negative 2 times a negative 12 is going to multiply to a positive 24. When I add going across, I get the negative 14, which is what I need, which means these are the factors that I'm going to use. Alright, now, a trinomial automatically factors into two binomials. Alright, when I have a leading coefficient of x, I know I'm going to have an x and an x, because when I multiply those first terms back out, x times x is going to give me that x squared. These are my two factors that multiply to a positive 24 and add to the negative 14 in the middle. So that means I have a negative 2 here and a negative 12. Technically those could have been reversed there. It would not have mattered. So my factored form of this trinomial is an x minus 2 times quantity x minus 12. Now you should check using FOIL to make sure that you've actually done this right. So we are going to throw a check in here. If I have factored this correctly, I should be able to take this x minus 2 times x minus 12 and multiply it back out and get the original trinomial I started with. So foiling it back out, first terms, x times x is going to give me an x squared. Inside terms will give me a negative 2x. Outside terms will give me a negative 12x. Last terms will give me a positive 24. Adding those middle terms there, I'll have an x squared minus 14x plus 24, and so it checks. I do have that original trinomial back when I multiply them out. Alright, taking a look at this second example here. Alright, I need two numbers that are going to multiply to a negative 21 and add to a negative 24. So again, I need a product here of a negative 21, and I need a sum of a negative 4. Alright, now stop and think about it. How am I going to get a negative product? Well, one of them is going to need to be negative, one of them is going to need to be positive. So again, start with an organized list. I could go 1 times negative 21. When I add that one, I'm going to get a negative 20. Okay, so that's good because that's telling me I need a negative sum. I'm going to get a negative answer there. Alright, if I tried a negative 1 times 21, that's still going to give me a negative 21, but then when I add going across, I get the positive 20. Alright, so what that tells me is when I'm picking two numbers which multiply together to get that negative 21, I'm going to want the negative on the bigger number of the two. Alright, so let's go through our factors of 21 in order here. 1 goes into 21, 2 does not, 3 does. 3 times 7. Alright, and again, I'm going to want that negative on the bigger number, so I'm going to try 3 times negative 7 first. 3 times negative 7 will give me negative 21. When I add going across, I get negative 4, okay, which is what I needed. So again, I have there found it after not too many tries. Alright, now knowing that this trinomial is going to factor into two binomials, my first term has to be x, because x times x is going to be x squared. I'm going to put these in basically in any order that I want. I'm going to do a plus 3 here, I'm going to do the minus 7 here. Okay, so there is my factored form. Now again, you should always check your answer, so let's throw that check in here. Again, I should be able to start with my factored answer, x plus 3 times the x minus 7, and FOIL it back out. First terms would be x times x, so x squared. Inside terms, plus 3x. Outside terms, negative 7x. Last terms, negative 21. Combining those two like terms in the middle there, I'm going to have an x squared minus 4x minus 21, which is the trinomial I started with, so it checks as well. Alright, so just two real quick examples here of how you would go about factoring those trinomials with a leading coefficient of 1. Obviously, after a while, you're going to get really good at this and not actually have to write all that out. But initially, when you first start learning this concept, keeping track of your factors and what they sum to is a really good way to organize your work and figure out what you're going to need in that factored form. Definitely. Okay, today we're going to take a look at a slide and divide method for factoring a trinomial that has a leading coefficient other than 1. Alright, so for my example right here, I've got 7x squared minus 26x minus 8. Alright, now for my first part, I am going to do the slide part of slide and divide. So I am going to take the 7 and I am going to slide it down to the 8, and I'm going to go 7 times 8 is 56. So then I will rewrite, since I've slid it down there, it's no longer in front, x squared minus 26x minus 56. I've slid it down there and multiplied 7 times 8. Alright, now I'm going to now factor this. This is a little bit easier trinomial with that leading coefficient of 1. So I'm going to be looking for factors of a negative 56 that sum up to the negative 26 in the middle. Alright, so you could just start listing them, negative 1 and times 56. Alright, but when I add there, I get 55, and even if I switch my signs, it's not going to be my middle term. If I do a negative 2 times 28, that's a negative 56, but again, if I add, I'm going to get a 26. Alright, oh, but now that's really, really close, so it looks like all I've got to do is change my signs there, make it a positive 2 and a negative 28. That will give me my negative 26 in the middle. Alright, so factoring this, now I have an x plus 2 and an x minus 28. Okay, now we have done the slide part of slide and divide. Alright, now I have to do the divide part. Once I slide that 7 over, then at the end I have to divide by 7 and divide by 7. Okay, now on this one right here, it does not divide out evenly. I can't take 2 divided by 7. So what I'm going to do is I'm just going to pull that 7 out in front and make this binomial a 7x plus 2. Alright, on this one though, 28 does divide by 7. That comes out to be a nice little 4. So x minus 4. Alright, and then there is your factored form for 7x squared minus 26x minus 8. Alright, now let's real quickly work through another example. Alright, let's suppose I've got maybe, say, a 3x squared minus a 17x plus 20. Okay, so again, I'm going to do the slide and divide. I'm going to slide the 3 over and multiply 3 times 20, which will give me a 60. So then, since I slid it over, it's gone in front. I've got an x squared minus 17x plus 60. Alright, so I need to factor this trinomial just like I always have. I need numbers that multiply to 60 and then have a sum of that middle term of negative 17. So I could do 1 times 60, 61, not going to work. 2 times 30, that'll be 32, still getting pretty far away. 3 times 20, that'll be 23, still not finding it yet. 4 times 15 is 60, and that will give me a 19, still not really close. 5 times 12, alright, it's going to give me a 17. Okay, so I'm getting really, really close here. Alright, but when I do 5 times 7 does give me a positive 60, but when I add I get a positive 17, I need a negative 17. Alright, so then my other alternative would be to go a negative 5 times a negative 12. That still gives me my positive 60, and now when I add I get the negative 17. Alright, so a little effort there in factoring that one. X minus 5 and then x minus 12. Alright, so we've done the slide part. Now we're ready for the divide. I've got to divide both these factors by 3. Alright, again, this one does not divide out, so I'm going to take that 3 and pull it out in front of that x. So this binomial is a 3x minus 5. This does divide out, so then I've got an x minus 4. So the trinomial 3x squared minus 17, x plus 20 factors down to 3x minus 5 times quantity x minus 4. Alright, now, not always will they divide out or even come up to something where I can pull it out. So let's do one more example with one scenario, one additional scenario that you might run into. Let's take a look at, say, a 9x squared plus a 15x plus a 4. Okay, so slide and divide. We're going to slide the 9 down and multiply it by that 4. Okay, it's gone there, so now it's just an x squared plus 15x and then plus 36. So I'm going to go back to my standard method of factoring this. I'm looking for numbers that multiply together to be 36 and sum to a positive 15x. So 1 times 36, and then when I add is a 37. 2 times 18, when I add I get 20, still not getting that 15 yet. 3 times 12 is going to be 36, and now when I add I do get 15. So there is factoring that basic trinomial. I will have an x plus 3 and an x plus 12. Okay, now this time I've got to do the divide part. I've done the slide, now I've got to divide. When I divide by 9 and I divide by 9. Okay, now neither one of these will divide. 3 divided by 9, 12 divided by 9. However, if you kind of look at these as fractions, alright, what you're going to need to do is if when you're dividing this is something that can be reduced, you're going to have to reduce it first. So then really I would have an x plus, and then it's going to be a 1/3 if I reduce that, and then an x plus reducing this, I will get a 4/3. Okay, now we don't want to leave it like that. I'm still going to do that pulling out in front. This is the part I would be dividing by the 3. I can pull that 3 out there in front. So I'm going to have a 3x minus, or 3x plus 1 and a 3x plus 4 for my final term. Okay, but the reason I wanted to go ahead and do this third example is because right here, alright, you do need to reduce if whatever's being divided doesn't divide out evenly, but it does reduce, so you want to reduce those fractions to be able to get down to your final factored form.